In this video, we're going to discuss solving quadratic equations using the quadratic formula. And so most of you probably have some recollection of something called the quadratic formula, okay? And it may be tucked away in those memories that you want to forget, but unfortunately you're going to have to pull them out, okay? However painful it might be. A quadratic, or the quadratic formula is this down here, this right here. And how we get there is, first you have to consider a quadratic equation in what we call standard form. So if you remember from the standard form that we talked about before, everything is on the left side, and then we're equaling 0 on the right side. Okay? So we need a quadratic of the form ax squared plus bx plus c. Okay? And then we make it an equation by setting that equal to 0. And here we have a not being 0. Okay? So if a was 0, we wouldn't have a quadratic. We would have a linear equation, and we know how to solve linear equations. So a being 0 is kind of boring. We need that to be not 0. Okay? And so there's the quadratic equation, and the quadratic formula is down below. Specifically, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And so there are various mnemonic devices and songs that people have come up with to remember the quadratic formula. I'm not going to make you sing any songs, but you will need to do whatever you need to do to remember the quadratic formula. Okay? And so, as you can see here, and we're going to talk about in just a second, we can pull some information from this quadratic formula without computing the whole thing. Okay? Specifically, what we're interested in is the whole thing, but especially the quantity b squared minus 4ac. Okay? The b squared minus 4ac. If that's negative, this equation has no real solutions. Okay? And you might wonder, well, how do we know that just based on if that's positive or negative? Well, if you look down here in the formula, in my bad arrow, if you look in the formula here, b squared minus 4ac is under that square root sign. And we know that if you take the square root of a negative number, you get something imaginary out. Okay, so it's not a real number, then it becomes an imaginary number. And we aren't dealing with imaginary numbers in this course, so it has no real solution. If b squared minus 4ac is greater than or equal to 0, okay, then the real solutions are given by this equation. Okay, so that's important. And actually, we'll dwell on this b squared minus 4ac business a little bit longer. B squared minus 4ac is called the discriminant. Okay, so it has a special name, and it's an important part of the equation because it not only tells us if there are possible solutions or no real solutions, it also can tell us how many of them there are. Okay, so we can go a little bit farther than just saying no solutions or 2 solutions. Okay, we can actually say if it's 2, 1, or 0. So as before, if it's less than 0, the third case, then there aren't any real solutions. If b squared minus 4ac is equal to 0, then there's going to be one solution. Okay, that may happen multiple times. So if it's equal to 0, then there's going to be a repeated real solution, which is called a double root. Okay, so if it's equal to 0, then there's going to be one solution that's repeated twice. Okay, or a double root. And then if it's greater than 0, then there are going to be two unequal solutions. So there'll be two different ones. Okay? So let's get down to the business of actually solving a quadratic equation using the quadratic formula. We'll start off with the sort of standard example. 3x squared minus 5x plus 1 equals 0. The most important part in using the quadratic equation to solve these types of the quadratic formula to solve these types of quadratic equations is that you need to identify what A, B, and C are. Okay, so A here, remember, before I start, remember that the formula, the form of the original quadratic equation was ax squared plus bx plus c. Okay, so it's plus through all of them. So everything is addition there. So we know from this equation that a is 3, okay, because that's a here, plus bx, and we have minus 5x. So that means that b is negative 5, and c is equal to 1. Okay, so now that we have a, b, and c, we can use the quadratic formula. And for our sake, I'll write it here again. A is equal to opposite b, or negative b, plus or minus the square root of b squared minus 4ac over 2 times a. Okay, and so now we substitute these numbers into the equation, and then we should get our answers back. So we have that x is going to equal the opposite of negative 5, which is positive 5, plus or minus the square root of negative 5 squared minus 4 times 3 times 1 over 2 times 3. Okay, so let's simplify now. 5 plus or minus the square root of 25, negative 5 squared is 25, and then 4 times 3 is 12, 12 times 1 is 1. So we have 25 minus 12 over 2 times 3 is 6, okay? And so then x is equal to 5 plus or minus the square root of 25 minus 12 is 13, 13 over 6. Okay, and so oftentimes the MyLabs Plus homework and I will want you to write this one step farther, write the two solutions separately. And so x equals 5 plus the square root of 13 over 6, and x equals 5 minus the square root of 13 over 6. Okay? And so these are the two non-equal solutions. And so we got that because 25 minus 12 is 13, which is greater than 0. And so from our previous slide, that told us we're going to have two non-equal solutions. Okay, so now let's get to a little bit tougher of a problem. 25 halves x squared minus 30 plus 18 equals 0. Okay? Whenever I have fractions here, the idea should be that you want to get rid of the fractions because you don't want to deal with any fractions in the quadratic formula. So what I can do is I can multiply both sides of the equation, so all of the left and all of the right, by 2. Okay, and multiplying both sides by 2 gets me what I want, because when I distribute this 2 through, what I get is 25x squared, okay, because the 2 and the 2 in the denominator cancel out, minus 60x plus 18 times 2, and 18 times 2 is 36, okay? And then on the right side, 0 times anything is 0, so that stays as a 0. Okay, now I can use the quadratic formula again, this time with much larger numbers. Okay, A is 25, B is 60, negative 60, I'm sorry, and C is 36. So the formula is 60 plus or minus the square root of 60 squared, negative 60 squared, plus, minus, getting mixed up here, 4 times 25 times 36, okay, all over 2 times 25. Okay, and so here there's a bit of arithmetic to do with some large numbers, and so we've got 60 plus or minus the square root of 60 squared, and 60 squared is equal to 3,600, or 3,600, minus 4 times 25, 4 times 25 is 100, times 36, which in turn is 3,600. So look at that, okay? So that tells us something there. B squared minus 4AC is equal to 0, which means I'm going to have one root that's repeated. All divided by 2 times 25, which is 50, okay? 3,600 minus 3,600 is 0, and the square root of 0 is 0. So I'm left with 60 plus or minus 0 over 50. And remember, this is what the possible x values are. So x is equal to 6/5. And 6/5 is actually repeated twice. Okay? Plus 0 and minus 0. So there is the second example. Okay. Now we get to a third example where x is on the right side. So I need to move that over. Okay, move it over. And I get 3x squared minus 4x plus 2 is equal to 0. Okay. I'm going to move through this one even more quickly just to save time, so you don't have to watch all this. A is equal to 3, B is equal to negative 4, and C is equal to 2. So I get 4 plus or minus the square root of negative 4 squared minus 4 times 3 times 2. Okay, 4 times 3 times 2, all divided by 2 times 3. This is x. X equals 4 plus or minus the square root of 16 minus 4 times 3 is 12 times 2 is 24, all divided by 6. And then I simplify further. 4 plus or minus the square root of 16 minus 24, and 16 minus 24 is negative 8. Negative 8 all divided by 6. Here we've got a problem because we've got a negative inside the square root. So the answer becomes x equals no real solutions. No real solutions. Okay, for example number 3. Let's move to example number 4, which looks quite a bit different. Looks quite a bit different than the other ones. I'll move this over here. X equals no real solutions. Okay. I have 9 plus 3 over x minus 2 divided by x squared equals 0. This is weird or odd because there are x's in the denominator and not in the numerator. And that's troubling for us. But we can fix this problem by multiplying each side by the largest denominator. And the largest denominator is x squared. If I multiply both sides by the same thing, it hasn't changed the value of the expression, but it sure does change how it looks. Okay, so when I distribute that x squared through, what I get is 9x squared plus 3x squared over x minus 2x squared over x squared, and then 0 times anything is 0, so 0 stays on the left. Oh, sorry, on the right. Now when things cancel out here, 1x goes away in the bottom and 1 in the top, and then in the third part of the quadratic, the x squareds just go away, and what I'm left with is 9x squared plus 3x minus 2. So look, lo and behold, what I've done here is getting rid of all the denominators and got my quadratic in the form I need to use the quadratic formula. Okay, and so A is 9, B is 3, and C is negative 2. Okay, so when I write out the quadratic equation, I have negative 3 plus or minus the square root of 3 squared minus 4 times 9 times negative 2 all over 2 times 9. So when I simplify, I get negative 3 plus or minus 3 squared is 9. So I have 9. This negative here in the negative 2 is going to make everything positive, okay, because we're going to have minus a negative number, so it makes it positive. 4 times 2 is 8, and 8 times 9 is 72. So I have here a square root of 9 plus 72 all over 18. And again, remember that this is x equals. Okay, 9 plus 72 is 81. Okay, and it turns out that the square root of 81 is 9. So we have, if we move this way, that x equals negative 3 plus or minus 9 over 18. Okay, and so I know we've run out of room here. I'm going to erase this in the bottom and wall off this. Okay, so to keep going, the two non-equal solutions that we get are negative 3 plus 9 is 6. So 6 over 18, x equals 6 over 18, which we can reduce to a third, or x equals negative 3 minus 9 is negative 12 over 18, which simplifies to 4 fifths, negative 4 fifths. Oh no, I'm sorry, negative 4. Silly me. Common to both is 3, and really common to both is 6. Okay, so common to both is 6, and so it's really negative 2/3. So it's 1/3 or 2/3 are my two solutions for that problem. Okay, so now we've seen a myriad of different examples where we could use the quadratic formula to solve quadratic equations. And so for the last thing of section 1.2, I want you to solve this quadratic equation using the quadratic formula.